Picture this: two massive aircraft carriers cutting through the ocean, one American, one European. From a distance, they look almost identical. Flight decks, fighter jets, pure military power. But here's the thing: beneath the surface, they're completely different machines built for completely different wars. And by the end of this video, I'll answer the most common questions people have about modern carrier warfare. Questions that most videos completely ignore. So let's dive into why these floating fortresses were never designed to match in the first place. First one, the numbers game reveals everything. Let's start with something simple. How many carriers does each side actually have? The United States Navy operates 11 nuclear supercarriers. Britain has 2. France has 1. Italy has 2 smaller carriers. Spain has 1. When you look at these numbers, you're not just counting ships. You're seeing completely different strategies written in steel. Here's what makes this interesting. America spends more on defense than the next 9 countries combined. And half of those countries are actually American allies. The U.S. built its carrier fleet to operate anywhere in the world without needing permission or help. European nations took a different path. They built carriers to work within alliances, to strengthen coalitions, not to replace them. And it shows. Right now, the U.S. has 3 more supercarriers under construction. No European country is building more than 1 at a time. The gap isn't closing, it's widening. Think about what this means in a real crisis. When something happens, America asks, which carrier should we send? Europe asks, is our carrier even available right now? That single word difference changes everything about how these nations project power. Multiple carriers create options. Options create flexibility. Flexibility creates confidence. And confidence determines how aggressively you can act. America can afford to station carriers in multiple oceans at the same time. Europe simply cannot do this. The numbers also reveal something deeper. They show different assumptions about how long wars will last. American carriers exist to fight for months or even years far from home. European carriers support shorter operations where allies share the burden. Fleet size creates redundancy, and redundancy is everything. If one American carrier needs repairs, 10 others keep operating. If France's only carrier needs maintenance, French carrier aviation completely stops. This isn't about one side being better. It's about different nations making different choices based on different needs. Second one, size actually matters in naval warfare. Now let's talk about something you can actually see. Physical size. The USS Gerald R. Ford weighs 100,000 tons when fully loaded. She's over 1,100 feet long. That's longer than 3 football fields. HMS Queen Elizabeth weighs 65,000 tons. France's Charles de Gaulle comes in at 42,000 tons. Italy's Cavour barely reaches 28,000 tons. These aren't just random measurements. They're combat capability translated into metal. A Ford-class carrier can hold 90 aircraft and 4,600 crew members. Italy's Cavour manages maybe 30 aircraft and 1,300 crew. That's not a small difference. That's a completely different level of sustained combat power. Bigger hulls mean more of everything. More jet fuel, more missiles, more bombs, more spare parts, more crew to work around the clock, more space for maintenance. All of this adds up to something critical. Endurance. European carriers chose smaller designs on purpose. Smaller ships cost less to build. They're cheaper to operate. They need fewer escort ships. they can fit into more harbors. Britain's Queen Elizabeth can access ports that would turn away an American supercarrier. But here's the trade-off. A Ford-class carrier can launch 160 aircraft sorties in a 12-hour period. Push it to 24 hours, and she can generate 270 sorties. European carriers can't touch these numbers. They were never designed to. Size also affects survival. Larger ships have more internal compartments, more redundant systems, more ability to absorb damage and keep fighting. Smaller carriers lack this resilience. The size difference reflects completely different operational concepts. American carriers work as independent floating air bases. European carriers work as pieces of larger Allied force structures. Both concepts work. They just work for different purposes. If you've served, you already know this. Size isn't about ego. It's about mission endurance and combat staying power. Third one, nuclear power changes the rules. Here's where things get really interesting. Power systems. Every single American supercarrier runs on nuclear power. One reactor core operates for over 20 years without refueling. These ships produce 400,000 gallons of fresh water every day. They generate unlimited electricity for decades. Fuel stops? Not necessary. The USS Nimitz once stayed at sea for 159 days straight. No port visits, no refueling, just continuous combat operations. Nuclear power makes this possible. Now look at Europe. Most European carriers use conventional propulsion, gas turbines, diesel engines. HMS Queen Elizabeth runs on integrated gas turbines. Italy's CATOBAR uses similar systems. Only France's Charles de Gaulle matches American nuclear capability. Conventional power creates limits. These ships must refuel every few thousand miles when running at high speed. They carry fuel oil instead of extra aviation fuel. They need constant port access or supply ships. Nuclear carriers cross oceans and stay forever. They can sprint at maximum speed without worrying about fuel. Their only limits are food and crew endurance. This completely changes what's strategically possible. France understood this. Charles de Gaulle's nuclear reactor enables long Mediterranean and Indian Ocean deployments. But France only has one nuclear carrier. When she goes into maintenance, French nuclear carrier capability disappears completely. The United States keeps 11 nuclear carriers operational. If 2 enter overhaul, 9 stay ready. This redundancy comes directly from the nuclear power decision. Nuclear reactors also generate massive amounts of electricity. Modern sensors need power. Advanced radars need power. Future laser weapons will need even more power. Nuclear ships provide unlimited electricity. Conventional ships must balance propulsion against electrical generation. Those of you who spent careers at sea know this truth. Fuel state drives every decision. Nuclear power eliminates that constraint. It's operational freedom through engineering. Before we continue, if you're finding this breakdown valuable, consider subscribing. It helps us create more detailed military analysis like this. Now let's talk about what makes carriers actually dangerous. Fourth one, the air wing makes the weapon. A carrier without aircraft is just an expensive boat. The air wing is what matters. American supercarriers deploy 75 to 90 aircraft per deployment. A typical air wing includes 48 F/A, 18 Super Hornets, 12 F-35C stealth fighters, 5 EA, 18G Growler electronic warfare jets, 5 E-2D Hawkeye early warning aircraft, and various helicopters. This combination provides strike capability, air defense, electronic attack, surveillance, and logistics support. HMS Queen Elizabeth maxes out at 36 F-35B fighters in combat configuration. Her total capacity reaches 72 when you include helicopters. Charles de Gaulle fields about 40 aircraft, including Rafale fighters and E-2C Hawkeye radar planes. Italy's CATOBAR can handle 10 F-35Bs in the hangar, 6 more on deck, plus helicopters. The numbers tell part of the story, but it's not just quantity, it's diversity and capability. American carriers use catapults to launch heavily loaded jets, steam catapults on Nimitz-class ships, electromagnetic systems on Ford-class carriers. These catapults hurl aircraft to flying speed in 2 seconds. This means fighters launch with maximum fuel and maximum weapons. They're ready for long-range strikes immediately. British and Italian carriers use ski jump ramps instead. Short takeoff and vertical landing jets like the F-35B take off up the ramp and land vertically. This offers flexibility, but sacrifices range and payload. These jets must be lighter at launch. France operates catapult systems like America. This gives Charles de Gaulle similar capabilities despite her smaller size. She launches fully armed Rafales and operates E-2 Hawkeye radar planes. But her deck size limits total aircraft numbers. Air wing composition determines what missions you can actually run. A large American air wing can simultaneously conduct strike missions, maintain air defense patrols, jam enemy systems, and run surveillance, all at the same time. Smaller European air wings must pick priorities. They can't do everything at once. Think about strike planning. An American carrier generates waves of 20 to 30 aircraft strikes while keeping plenty in reserve for defense. A European carrier might launch 8 to 12 aircraft per strike with minimal backup. Electronic warfare deserves attention here. EA-18G Growlers jam enemy radars and communications. They protect strike packages and blind defenses. European carriers usually don't have dedicated electronic warfare aircraft. They use multi-role jets with jamming equipment or rely on Allied support. The E-2 Hawkeye provides another massive advantage. This flying radar plane sees hundreds of miles in all directions. It coordinates air defense and manages the entire battle space. American carriers carry 4 or 5 Hawkeyes. France has 2. Britain uses helicopters with radar systems instead. Helicopter radar works, but flies lower with less endurance. Fixed-wing radar planes stay up longer and see farther. This gap matters enormously in missile defense. Fifth one, launch systems control strike speed. How you get aircraft into the air determines how fast you can fight. American carriers perfected catapult systems over decades. Steam catapults on older ships use pressurized steam to accelerate aircraft from 0 to 150 miles per hour in 2 seconds. 4 catapults mean simultaneous launches. Jets cycle rapidly off the deck. Ford-class carriers introduced electromagnetic launch called EMALS. Linear motors replace steam pistons. EMALS delivers smoother acceleration with less stress on aircraft. It launches different aircraft weights more efficiently. Landings use advanced arresting gear that catches jets electromagnetically. These systems enable relentless high-tempo operations. Launch aircraft, recover returning jets, rearm and refuel on deck, launch again. The cycle repeats dozens of times every day. British and Italian carriers skipped catapults completely. Their ski jump ramps curve upward at the bow. F-35B jets accelerate, shoot up the ramp, and climb away under engine power. They land vertically using thrust. STOVL operations simplify ship design dramatically. No catapults means no complex steam systems or electromagnetic launchers. Maintenance becomes easier, but launch tempo suffers. STOVL takes more time and limits what weapons you can carry. France's Charles de Gaulle uses traditional steam catapults. This gives France flexibility in air operations. Rafales launch with heavy bomb loads. E-2 Hawkeyes provide radar coverage, but with fewer catapults operating at once, launch tempo stays below American levels. Consider a 2-week air campaign. Day 1 might look similar across all carriers. Day 5 shows differences emerging. Day 15 reveals the massive gap. American carriers maintain brutal tempo. European carriers carefully manage resources for critical strikes. Launch systems also affect landing operations. Arrested landings with tailhooks work in any weather. Vertical landings struggle in rough seas or high winds. Operational availability changes with conditions. The choice between catapults and ski jumps reflects strategic thinking. America expects sustained campaigns requiring maximum tempo. Europe expects coalition operations where multiple nations share the workload. 6.1. Maintenance determines real availability. Here's something most people miss. A carrier in maintenance generates zero combat power. The U.S. Navy uses a 36-month cycle called the Optimized Fleet Response Plan. Each carrier rotates through maintenance, basic training, advanced training, and deployment. This schedule keeps multiple carriers always available while others refit. Reality gets messy. Maintenance runs late. Parts arrive slow. Unexpected problems emerge. But the system design provides backup. If one carrier delays, another fills the gap. European nations face brutal availability problems. France operates one carrier. When Charles de Gaulle enters major refit, French carrier aviation completely stops. From February 2017 through late 2018, she spent 14 months in overhaul. French pilots trained on American carriers during this gap just to maintain skills. Britain has 2 carriers, which theoretically provides backup. But both cycle through maintenance. HMS Queen Elizabeth spent 7 months in dry dock during 2024. When one British carrier sits pierside, Britain fields half its carrier force. When both undergo work, capability drops to 0. Nuclear carriers face especially intense midlife overhauls. Refueling and complex overhaul replaces reactor cores and modernizes entire ships. USS George Washington spent nearly 6 years in this process. 69 months, almost $3 billion. She emerged completely rebuilt. But America has 10 other carriers operating during these overhauls. The fleet keeps functioning. Single-carrier nations enjoy no such luxury. Availability determines deterrence value. A carrier at the pier might as well not exist. Adversaries ignore inactive ships. They respect deployed ones. Your operational experience confirms this truth. Readiness isn't yes or no. It's a percentage game across entire fleets over time. 7.1. Industrial capacity wins long wars. Carriers fight only as well as the shipyards that maintain them. America maintains multiple carrier-capable yards. Newport News builds and refuels nuclear carriers. Puget Sound handles West Coast overhauls. These facilities employ thousands of nuclear-trained engineers. They stock specialized parts. they maintain decades of institutional knowledge. This industrial base enables sustained warfare. Damaged carriers return for repair. Old carriers enter for upgrades. New carriers launch on schedule. The system continuously regenerates combat power. European nations maintain capable yards, but at smaller scale. France services Charles de Gaulle at Toulon. Britain uses Rosyth and Portsmouth. But these yards handle fewer carriers less frequently. Expertise concentrates in fewer people. Consider wartime. If America loses a carrier, yards can repair her. If damage proves catastrophic, other carriers continue fighting while replacement construction begins. Industrial capacity supports sustained conflict. European nations face grimmer math. Losing a carrier might eliminate carrier aviation for a decade or longer. Quick replacement capacity doesn't exist. Construction timelines stretch across 10 to 15 years minimum. France's next carrier, the PANG program, won't arrive until approximately 2038. Even with political will and unlimited funding, you cannot rush carrier construction. Industrial pipelines take years to establish. Those who understand logistics know this. Combat units get attention. Industrial base gets ignored. But wars are won in factories as much as battlefields. Eighth one, trained crews are the real weapon. A carrier works only as well as the people operating it. American carriers need 4,500 to 5,000 crew members, nuclear reactor operators, catapult officers, fuel handlers, ordnance technicians, radar operators, aircraft mechanics, medical staff, hundreds of specialties working together. Nuclear training alone takes 2 years. Aviation specialties require months of technical school plus on-the-job training. Flight deck operations demand perfect coordination from dozens of specialists in dangerous, confined spaces. The U.S. Navy trains thousands of sailors annually. When experienced personnel rotate out, trained replacements arrive. The system maintains continuity despite constant turnover. European navies run smaller training pipelines for smaller fleets. Britain's Royal Navy fell 1,000 people below target in 2024. Shortages hit technical roles hardest. Nuclear engineers, aviation technicians. When you have 11 carriers, you absorb training gaps. When you have 2 carriers, every shortage hurts. Losing a dozen specialists barely impacts American readiness, but could ground a European carrier. France maintained continuous carrier operations, preserving expertise. But one ship limits how many specialists you can train. Pilots compete for limited flight hours. Deck crews get fewer practice opportunities than Americans with more ships available. Technology matters. Trained people matter more. Ninth one, radar coverage equals survival. Seeing threats first means surviving them. American carriers deploy E-2D Hawkeye radar aircraft. These planes fly high with powerful sensors. They detect incoming threats hundreds of miles away. They coordinate fleet defense and manage complex airspace. France operates E-2C Hawkeyes from Charles de Gaulle, usually 2 aircraft. This gives France meaningful early warning. Britain faces constraints. Queen Elizabeth carriers cannot launch fixed-wing radar planes. Instead, Britain developed Crow's Nest, helicopter-based radar fitted to Merlin helicopters. Crow's Nest works, but helicopters fly lower and slower than fixed-wing aircraft. This reduces radar range and flight time. A Hawkeye patrols 4 to 5 hours at high altitude. A Crow's Nest helicopter manages less time lower down. The radar picture determines everything in modern combat. Anti-ship missiles approach at supersonic speeds. Early detection provides critical minutes for defense. Imagine two carrier groups facing attack. One detects threats at 200 miles. The other detects at 100 miles. Both defend, but the first group gets twice as long to react. More missiles dive farther away. The carrier survives. Information dominance wins engagements. Radar reach equals survivability. 10th one, different wars, different designs. Ultimately, carriers answer one question. What war are we preparing to fight? American carriers project power globally in sustained high-intensity conflicts. They assume extended campaigns far from home against peer enemies. Large size for endurance, nuclear power for unlimited range, massive air wings for sustained strikes. Everything flows from this assumption. The United States built carriers expecting wars lasting months or years across multiple oceans. World War II's Pacific campaign shaped this thinking. That doctrine evolved, but never fundamentally changed. European carriers accept different missions. Power projection within coalitions, regional conflicts, political signaling, crisis response, contributing to NATO operations where allies provide supporting capabilities. European nations don't expect to fight peer adversaries alone for extended periods. They expect alliance warfare with shared burdens. One nation provides carriers, another provides tankers. Together, they create capability. This explains everything. Fleet numbers, size, propulsion, air wings, launch systems, maintenance, industrial base, crews, and radar all flow from strategic purpose. Neither approach is superior in absolute terms. They're optimized for different strategic realities. Now, let's tackle those questions I promised at the beginning. First question, if American carriers depend so heavily on logistics, doesn't that make them vulnerable in real war? Yes, but specifically their supply chains, not the ships themselves. Carriers need fuel, ordnance, parts, and trained crews constantly. Their vulnerability lies in disrupting logistics. However, America built a regenerative system with multiple carriers, supply routes, and repair facilities. Even if enemies disrupt logistics temporarily, the system adapts. Other carriers rotate in. The question isn't whether one carrier survives, but whether America sustains the system faster than enemies can disrupt it. Second question, why doesn't Europe just build more carriers to close the gap? Because carriers aren't just ships, they're entire national ecosystems. Building more carriers requires doubling pilot training programs, duplicating maintenance facilities, sustaining escort fleets, and funding decades of operations. Europe invested in land-based air power, submarines, and alliance commitments instead. Matching America would require completely restructuring European defense beyond just shipbuilding. Third question, in future war, who would use carriers more aggressively? America, without question. Having more carriers makes each one politically cheaper to risk. Losing one would be catastrophic, but wouldn't end American carrier aviation. Europe faces the opposite problem. With one or two carriers, each becomes strategically precious. Political leaders grow cautious because single losses remove national sea power for a decade. American carriers shape escalation early and rotate continuously. European carriers operate selectively with Allied support. These 10 reasons prove carriers never failed to match. They were built for different wars under different assumptions for different alliances. America created global response instruments. Europe created coalition capabilities. Both work for their intended purposes. Understanding these differences matters more than declaring winners. If this analysis provided value, subscribing helps us produce more detailed breakdowns like this. Thanks for watching,